Hi everyone, this is Miss A. Welcome back. This is page 3 of your team review. So we're going to jump right into this. First 5 minutes are going to be just going over the direct answers of this page, and then afterwards I will go into a deeper explanation of the standard and how I got my answers. Feel free to jump around in this video. If you only need to look at 3B for a deeper explanation, then do so. Don't feel like you have to listen to me ramble the entire time. Okay, let's look at the first one. A line has a slope of -3 and goes through the point 3, -4. Determine the equation of the line. So I'm given a slope, and I'm given a coordinate point, an x and a y value. So I'm going to use the equation y equals mx plus b. I know this is going to be -3/1. I have an x value of 3, and I have a y value of -4. So I'm going to put all that together, and the only thing I don't have is plus b. So -4 equals -3 times 3 plus b. Solve for b, and you end up with 5 equals b. So now the question asks you to determine the equation, so we're not done here. The actual equation will be taking the slope that was given and then plugging in our b value that we didn't know. So the true answer is y equals -3x plus 5. All right, moving on to number 2, or 3b, sorry. All right, determine the equation of a line connecting the points -4, -9, and 2, 3. So determine the equation of a line connecting the points -4, -9, and 2, 3. Some of us may have -9, -4, and 3, 2. Please switch those at this time so they look like this. So our first step will be to find the slope, and we're going to use the slope formula of y2 minus y1 over x2 minus x1. So first we need to determine what's our y2s, what's our y1s, so on and so forth. So I'm going to take this first coordinate point and just make this my x1 and my y1, and this my x2 and my y2. Now I'm going to substitute these values into their correct spot in this equation. So I'm going to put 3 minus a -9 over 2 minus a -4. And once you simplify, you end up with 2. All right, the second part of this equation is we now need to find the b, or the y-intercept. Find the y-intercept. This is a lot like the first question. So we're taking those same exact steps because we know what our slope is and we're given a coordinate point to use. It doesn't matter which coordinate point you use. Either is fine, but I'm going to take the second one. So I'm going to do 3 equals 2 times 2 plus b. It gives me 4 minus 4 on either side. You get -1 equals b. So my equation is y equals 2x minus 1. There you go. All right, moving on to 3c. Will the systems of linear equations created by two lines described above intersect? If yes, what is the solution? If no, explain why not. Okay, so we need to take the two equations that we created in 3a and 3b, and we need to see if they will intersect at one particular point. We say that we want to find an x value and a y value that make both of them true and equal to each other. So I'm going to set -3x plus 5. This is the equation from 3a. And then I'm going to take the equation from 3b, 2x minus 1. And then I'm going to solve for my x and then plug that in to solve for my y. So x equals 6/5. All right, so we're going to take that and plug it into one of the equations that we have created from 3a or 3b and then solve for y. I'm going to take the second equation, y equals 2x minus 1, in order to solve for my y. So y equals 2. I'm going to plug in the 6/5 here for my x value minus 1. Okay. All right, once you have the same bases for 12 over 5 and 1, you end up with y equals 7 over 5. All right, so the solution for this is going to be 12/5, comma 7/5. Could also have this as 1.2, comma 1.4. Both answers are all right. All right, so that's the kind of quick explanation and answers for this page. Let's jump back to 3A. So if all you want to know was the answers for this, you can tune out at this time. I'll see you later. If you want a deeper explanation of some of this stuff, please stay tuned. All right, I think I'm going to jump over to 3B as I believe that this one has the most complicated process, at least to start with, because one, you need to find the slope, and then you also have to find the y-intercept. So the way that this page is kind of set up is that 3A kind of gives you the second step for 3B, but there's a first step that you haven't gotten to yet. So we need to find the slope by finding the difference between our y's and the difference between our x's. So if we had this on a graph, we had -4, -9. So this might be down here. This would be -4, -9. And then 2, 3, to make that a different color, 2, 3 might be up here. We have 2, 3. What you're doing here is finding how our x values change and our y values change in order to see how far apart, in other words, these coordinate points are. So from -4 to 2, I would have to add 6 on the x-axis, so this would be plus 6, and then from -9 up to 3 would give me, that's where we get this part in here. Before we get our 2, this was 12 and this was 6, and when you divide that, you're going to get your slope of 2. So slope is always the most reduced form of how our x's and y's change. So when you do slope, y equals the change in y over the change in x, we want to try to get the smallest, the most simplified version of our slope for our equation. So even though 12 over 6 is equivalent to 2 over 1, we want the 2 over 1 versus the 12 over 6. It makes doing the math a little bit easier in the equation. And then to find our y-intercept, remember from, I believe, video 1 or 2 that I did, the y-intercept, the rule of that is that x is always 0 and y can be any number. So x has to be 0, has to be always 0, and then be any number. And then just like what we did in this side, when we were given two coordinate points and a slope, we have a slope now, and we actually have 2 pairs of coordinate points that we can choose from. So it doesn't matter which one we choose because they both lie on the same line. We can just plug it into the formula y equals mx plus b, like I did over in 3a, where I had y to be -4 and m was my -3 and my x was 3, and all I wanted to do was find my b value. You do the same process here, where you plug in, I chose -4, 2 and 3 versus -4, -9. If you want, you can give it a shot and see which, let's actually do that right now. Let's see. I'm telling you right now that you're going to get the same b value. Let's see what happens. So versus 3 equals 2 times 2 plus b, let's do -9 equals -4 times 2 plus b. Negative 4 times 2 is going to give me a negative 8. I want to get all my integers to one side, so I'm going to add that 8. Negative 9 plus 8 is going to give me negative 1. There you go. So whenever you're saying determine the equation of a line connecting the points, they share the same equation, meaning that this equation, y equals 2x minus 1, this equation represents these two coordinate points. These two coordinate points, this x, this y, makes this statement true. They equal each other. All right, and then down here for 3, builds off of 3a and 3b. We're looking at a system of equations. So if you remember from 1a, we looked at something like this where we had a graph, we had a point, and then we made a line here, and then we made another line here. Oops, try that again. We made another line here, and it was at this point that it was the solution, okay, to the system of equations, meaning that this one coordinate point made both of these equations true, and they shared it at the same time. So in order to find that solution, we have to set them both equal to each other. You could also think of this as the fact that we're looking back at these equations, y equals negative 3x plus 5 and y equals 2x minus 1, that they both equal y. And when they both equal y, the same variable, they must equal each other, so we can set them equal to each other. And then you solve for x, and then you plug in one of the values to solve for y. All right. That's all I have for you guys right now. If you have any particular questions, please feel free to email me on Schoology. I'm more than happy to ask or answer your questions. Again, Miss Alexander is always available for you guys at morning math. I believe that she is handing out Mercer money for those students who show up. $1 per session. $1 per session?